Okay, so here we are in class again. Hopefully we can hear me well, right? And then we're looking at Pythagorean theorem and then some special cases with right triangles. I'm going to be honest, this is going to be a huge memorization factor. I'm going to throw stuff at you today. Going to derive one of them, the 45, 45, 90s, where the relationship comes from. But Jen, you got to lock it in. I always tell my students, there isn't, I don't get it. That's not allowed in certain things. Certain things you have to have memorized, and you just don't have it memorized yet. And say it that way and not, I don't get it. Sometimes it's just not feasible to say that. You just got to get it memorized. Just like chemistry, you got to memorize like some elements and memorize things about it. Once you get all that stuff memorized, then you can proceed on and use it. Well, we are going to start basic. This is grade school kind of stuff. It's all based off of the Pythagorean theorem, what we're going to show you about 30, 60, 90s, and 45, 45, 90s. So, would you take all of this as notes? As I, before the video started, talked about the power of taking notes and why you do it. Now, you have to write all the words, but here is the Pythagorean theorem, which I'm sure we all remember and know. So we do have to start with that and simplify using the Pythagorean theorem and remind you about square roots, all right, and how you do that as well. But if it truly is a right triangle, then the side measures will fit that relationship. A squared plus B squared equals C squared. One thing I'm going to highlight, the hypotenuse is the side across from the right angle. And it usually is denoted by the letter C in the Pythagorean theorem. So we can keep that as a, throughout all types of questions, that's what they usually do. Okay, and then the first thing is, as far as notes are concerned, you have to write all these words down. Maybe not. Just solve for the missing side would be good enough. But identify the unknown side as a leg or hypotenuse, then find the length of the unknown side. Leave in simplest radical form. That's your homework, Chief, not the notes. You can put that away. All right, I saw that you look confused. Okay, so just find the missing side. And I'm not, because of time, going to label all the sides. I'm just going to label the hypotenuse with a highlighter. So Ethan, that is the hypotenuse. That means the other two things are called legs. Or we're just going to verbalize that it ain't a big deal. So I'm not going to ask you this, because I think we all know. There we go. Okay, what I'm going to ask you is 36 plus 81. I just did this last hour. I think it was 117. Not Ethan, anybody. How come I know that this is divisible by 9 right off the bat? How did I know that fast? How did I know 117 is divisible by 9? Anyone? Raise your hand. Nice. The digits add up to 9. It's only with 9 and 3 that this is true. 1 plus 1 plus 7 is 9. 9 goes into 9. So 9 goes into 117. So right off the bat on my calculator, for those that struggled with this, I know it's 9 times something, and I think I found it to be 9 times 13. Because now when I square roots, Ethan, what's the square root of 9? I can ask this everyone, they know it. 3. So why can't people write this as 3 root 13? I don't know. By the way, I should put plus minus on that. I want to keep hammering the point. When you square root both sides, you're supposed to put plus minus because it is a positive negative that squared equals that number 117. But for geometry, you can only have positive sides. So you select the positive, all right? So I do keep writing that. So in a geometric sense, you're not supposed to write the negative, and I would have to take a half point off if you did. So I know that's algebraic, geometric. You asked me to write the plus minus last semester, now not this semester. It's because it's a different question. That is the reason. Then the only reason I'm going to cover this one, just to make sure, Matt. First of all, what's the hypotenuse, Matt? Boom. And then the other two are called legs. Let's just get over it. Knowing that, what's the square root of 7 squared, Matt? Just freedom. Those are opposite operations. You're right. And the square root of 19 squared is 19. free. And then, Matt, subtracting 7, what's square root of 12 simplify to? You're right, because 12 is 4 times 3. Square root of 4 is 2. So now we're back to the simplifying square roots. That is why, we got to get our stuff done so we can move on and use it later. This is a huge concept throughout the whole year of simplifying radicals. Okay, all right, so that's simple use of the Pythagorean theorem. I did go into this one. Here was 3 questions here. There's no way we could get through all of these, like connected triangles. What do we do? So I guess I will because of time. It's the same thing. Find a value for x, leave it in simple radical form. Really going to zoom in on this. Okay, let's call this triangle 1, 2, and 3. And then where are we at? Gracie back there. Which one do I have to work with first in this connected drawing in order to get the ball rolling to find x? Ooh, if I went to triangle 1, do I have enough information to find like what x is? No, so where do I have to go first? What has enough information to find the third side? It's number 3. So what I did in the other hour is I made that just like y. I wanted to call it a different variable. Okay, now which one's the hypotenuse here, Gracie, in this bottom triangle 3? What's the hypotenuse? 24. Okay, so knowing that 24 is the hypotenuse, to solve for y, it's y squared plus 16 squared, big numbers, equals 24. And I actually am glad I'm going to do this because we have a lot of radical stuff on here. And I'll show you what I do here, Gracie. I'll help you out. Clear. What I'm doing on my calculator is 24 squared minus 16 squared. I should show that on the screen. My calculator's back working. But I think you can handle that without seeing that. Now, here's what I did, Gracie, last hour. I figured this out real fast. I don't like the big trees, the big mess of like divide by 2, divide by 2. I know right off the bat, off to the side, that this is 32 times 10. Just, some basic multiplication rules. And then from 10, 10 is 2 times 5. I take that 2 and hit the 32 with it. What's 2 times 32? So this is 64 times 5. That's all I did is I took that 2, and then I know that this is a perfect square. This is how you simplify these things pretty easily. Oh, okay, good. All right, so I do have to go to the. All right, thank you. I got to do the attendance now. So, I can't stop my video though. Just make sure I take attendance at the end of this. Mark you in. All right, because I don't want to have them see your names on the Infinite Campus here. Anyway, so this is, for time purposes, let's just ignore the negative. Just say positive. Square root of 64. What is the square root of 64? 8. Okay, so I'm going to write that quickly. Sorry, got a little thrown off there. This is 8 root 5. But now watch what I do for the next triangle. This is now 8 root 5. You know what? I'm going to get those 1, 2, 3s out of there. That was just for the first question. Which triangle do I use first? So now that this is 8 root 5, I can proceed on and then go to the next side that I can find, which is, I'll call Z. All right. And then Ryan, who's the hypotenuse in this triangle? It's Z. So that's got to be by itself. Watch what I do, though. I didn't finish my thought. I'm going to go back to root 320 because this is root 320 that I just simplified it. When I use that to find Z, which I'll go green here, then I'm going to do 14 squared plus, I'm just going to go back to that 320 because the root 320 squared is just 320 instead of having to deal with the 8 root 5. It's really the same thing, and we should know that. Then I'm going to go to my calculator. This is some big numbers. This is going to be 320 plus 14 squared, 516. Now listen to what I do with this one. Listen. I'd go to my calculator. I would actually divide by 2. I divide by 2 again. I got 129. Okay, so I divided by 2 twice. This is off to the side, 4 times 129. Hey, 129. 1 plus 2 plus 9. What does that add up to become? 12. What goes into 12? 3. 3. That's the other special divisibility rule. So I'm going to divide by 3. Oh, and I got 43. Anyone know what 43 is? Starts with a P. Prime. So that's it. 129 is 3 times 43. There is nothing else to break out of there. So that is what I want 516 to look like. A perfect square times another thing that doesn't have any perfect squares left over. It's just 3 times 43. All right, and then that is z equals 2 root 129. Don't understand why students have a problem with this. I can ask everyone what's the square root of 4, and you tell me 2. I can ask everyone what's the square root of 64, and you can tell me 8. But why we can't break these down, I don't know what the mind block is. I'm not really sure. All right, and then I'm going to stop here. But now that we got this 2 root 129 for this side, I did do this with the other class. How would I find x? 32 is the hypotenuse. So it'd be x squared plus, instead of 2 root 129, I would just write root 516 because that's where this came from. Squared equals 32 squared. And then you continue the process. Let's move on though. Okay. I think we get the point on that. Tough to make that a test question because if you miss the first part, all the rest is screwed up, right? Miss the first side, then all the rest are going to be wrong. So good ideas there. Good work with radicals. Good reminders of that stuff. Okay, now I'm going to do this for the video purposes and stay here. I have my stuff right here as well for this. And then feel free to write this down as I go through this. It's a very simple concept. If we taught 5 days a week, 1 hour, or we used to have 51-minute class periods, we'd have time to do this. And a common thing that teachers would do is give you spaghetti, pieces of dry spaghetti, not cooked, and give you various lengths and ask you to make triangles out of 3 pieces of 3 pieces of spaghetti. Very simple and cheap to do. So looking at this, let's say this is one of them. See this ruler, everyone? Look up here. And then these 2 pens or markers. Then I would say try to make a triangle out of this. So sorry if it's hard, far away for you to see, but okay. So the first thing you would do is try to put this right here and make an angle connecting these 2 sides. Then maybe the next thing you try to do is try to connect this side here and make that angle. And then what doesn't happen with these 2 markers? What doesn't happen? They don't connect. All right. So can I make a triangle with these 3 sides using the lengths that I'm given here? No, you can't. All right. Because the 2 smaller sides, when added together, are actually smaller than the biggest side. So they can't connect and make a third valid angle measure. And that's what we used to do just to hammer down what this says right here. If I give you 3 sides, I'm a jerk if I give you 3 sides and 2 of the smaller sides don't add to the third side or bigger than the third side. Can't even be equal. If it was equal, then these 2 sides would just lay on top of that third equal side. As soon as I try to lift it, it'd slide off of the vertex and not be able to make a triangle there either. So that's what this says right here. So be careful before you proceed on with this. As long as you have a valid triangle, then the converse of the Pythagorean theorem says if they fit the Pythagorean theorem, a squared plus b squared equals c squared, then that has to be a right triangle. So it's just the reverse. Previous questions, you were given a right triangle, find the missing side. Now you're given sides. Tell me it is a triangle. Tell me if it's a right triangle. So that's the idea coming up here. Won't spend too much time on this. Got to get to the memorization factors of things that we got to do here. So I'm going to pause or freeze. Can't pause. Freeze that so you can see that. I just got to check some stuff here on the video. You'll see what I'm doing here. Okay, good to go here. Still can't take attendance. Darn it. I did take attendance. I got to make a change. Okay, so unfreeze for class. Okay, so if the sum of the squares of the lengths of the two sides of a triangle are equal to the square of the length of the third side, then the triangle must be right. It's just saying the opposite. So if a squared plus b squared equals c squared is true, you have a right triangle. So where are we at? Hannah. Thanks for being honest, Hannah, right? And I'm frozen here. There we go. Yep, frozen. Okay, so that was the last one we did. Boom. All right. Hannah, first of all, do I have a triangle with these three sides? Yes or no? Oh, I thought I asked this to the person last hour, and she said no, and I was like, I'm like, but then I stopped. Is it yes or no? What's 14 plus 11? 25. Remember what I just said about that? Okay, these are equal to the third side, not greater than. So no, this is not a triangle. What would happen with those two smaller sides is they would just lay on top of the third side perfectly, the exact length. As soon as I try to make angle measure out of it, it slides off of a vertex. And therefore, I hope you know what I mean by that. All right, showing the smaller one. So that's not a triangle. We move on. Hannah, how about this one? Yes or no? Yeah, I mean, it's kind of easy. 36 plus 25. You don't even have to know exactly what it is. It's way bigger than 49. Well, yeah, I think it is way bigger. But you do have to know that this is what would have to happen next. So it is a triangle. There is the old question mark equal sign. Does this hold true? And please make sure you try to make the largest side the hypotenuse, although it may very well not be. So is this true? That's the point of this. Do these make a right triangle or not? Ethan, it looks like you're calculating. Did you get the numbers or no? No? Oh, I thought you were typing on your calculator. Okay. No. Oh, I got to screw up here. Feel free, anyone, to help me out here. We're live. 1921. Great year, by the way. 49 squared. The roaring 20s, right? Before the stock market crash. After World War One. No, that is not equal. So it's a triangle, but it's not a right triangle. Not with a right angle because it doesn't fit the Pythagorean theorem. Okay, so just that's good enough for the idea of this one. I think on this one we did do. Come on, 72 plus 30 is way bigger than 78. So I do have a triangle. And I think when we checked in the Pythagorean theorem, it did end up being equal when I checked the Pythagorean. So you'd say it's a triangle and it's right. But I am going to move on, so that we can maybe look at one of these. And I'm going to be honest, there's a lot more applications in your homework. I have like 4 for the notes or 3. It's too many. All you have to do with an application, a word problem, is make a drawing out of what you're reading. And then as you're writing this down, I'm going to make an argument again. Well, these word problems, teachers do this for just to torture us. Well, remember I bragged at the beginning of August, I did a whole bunch of stuff in my house. And it was so much math involved. It was a whole bunch of word problems. I had to look at a situation and figure out what I needed material wise. And it's its own little word problem that you're imagining in your head and you're writing on the paper so that you don't buy too much or don't buy too little. So therefore, you have to make another trip, and it costs money to do that stuff. It's about maximizing those scenarios. So that's why we do these little word problems, because life ends up being a word problem when we have to do stuff when we get older and get more responsibilities. So it's a very simple process here. 20-foot ladders resting on a house. I don't know. Draw my house real quick. There it is. Beautiful. We're going to assume that the land is horizontal. All right. And the house is not crooked. All right. It goes vertical, straight up and down. So we're going to assume the right angle when we lay this ladder up here. And then the ladder kind of looks like this. and it's 20 feet. So it's amazing how many students I find not putting the things in the right spot. The ladder leans up against the house and it's 20 feet long. So that is the 20 right there. And it says the base of the ladder, base is the bottom, is 4 feet away from the house. Sometimes they say the foot of the house. I know houses don't have feet, but it's getting the point that it's, right down at ground level kind of situation there. How high above the ground does the ladder reach the house, which is this X here? All right. And then for leaving you alone purposes and moving on to the stuff we have to have memorized, we'll get this complete and done. Notice what it says on this one, different than the previous ones, round to the nearest tenth. Because in the real world, we want to know that decimal approximation of what we're dealing with here. So on my calculator, I just type 20 squared minus 4 squared, 384, and then I square root that and just get the decimal 19.59, which is 19.6 feet up the house there. Okay. Yeah. So a silly little word problem, but that's the idea of just making sure you can make a drawing and go from there. Any questions so far before we get into the memorization factor of 45, 45, 90s and 30, 60, 90s? In a good spot here. Okay. Here's our first special right triangle, and I can actually prove this one. I can derive this one. The 30, 60, 90, when I end the notes just telling you what the 30, 60, 90 relationship is, you're going to have to memorize, okay? But here's what's true about all 45, 45, 90s. First of all, let's make sure we understand what does it mean to be a 45, 45, 90? These are the two congruent angles, both 45 degrees there. Remember, the sum of a triangle, the angles add up to 180. And it also makes these isosceles. So I'm going to go ahead and mark those two sides as equal. The sides opposite the 45s, those would be equal side measures. So here's how it starts. I pick a letter, and I don't know what Mr. Sonowski's doing. I don't know what Mrs. Fasola is doing. I'm picking the letter A. I remember books that would use A as a unique variable to label this out. And they call one of the sides side A. That's its length as a variable. So definitely what's true is this side would also have to be side A because they are equal. So those are A and A. This is what's true about 45, 45, 90s always. The hypotenuse will therefore be whatever A is times the square root of 2. And that's what you have to have memorized for a 45, 45, 90. Right now, with my CAT students, that'd be 2 years away for you if that's the path that you take. We are doing this right now as a reminder so that we can move on for trigonometry, which is what your world's going to start doing too. I can prove this. I can put a 45, 45, 90 over here and then pick an actual number. Last hour, I randomly picked 7. Just said, you know what? Let's say that side is 7 inches. I don't care. Well, then that means this has to be 7 inches because these are isosceles. Those two sides have to be equal. Now let's call this X and find it. This is the proof of the relationship that I just came up with over here. So what's true about the Pythagorean theorem is the two legs squared, that sum is equal to the hypotenuse squared. 7 squared is 49. 49 plus 49 is 98. Lo and behold, 98 is 49 times 2. And when I square root both sides, this becomes 7 root 2. Square root of 49 is 7, root 2 stuck in jail. There you go. A root 2. 7, 7, 7 root 2. I don't care what I would have made that side measure. If I would have made this 19, then this would be 19 root 2. Guaranteed if I would have went through the Pythagorean theorem again. Doesn't matter. All right. And that's what holds true. So my first dude, let's go on. Oh no, actually, David wasn't sure. So David, I'm gonna give you put you pressure on you. You got the easy one here. So I got a 45. I got a 90. We should know that this is 45. Adds up to 180. What does that make X? You wouldn't even need to know that relationship. We should know that that's 6, right? What does that make Y based off of what you just learned there without doing the Pythagorean theorem? That's the point of this. Now we can, if we know these relationships, we can find these side measures faster than doing the Pythagorean theorem. And that would be true. David got an easy question. Who's next? Genevieve. But I went last time. We're moving on. Now this is tougher. Wait till I ask you the question here. Okay, oh no, I got to find X, which is the what? What is that called, Genevieve? It's the hypotenuse. Good. But we got a problem. And what you really could do is do the Pythagorean theorem. Let's keep that in mind. But we're trying to do a little faster if we know that we have a 45, 45, 90. By the way, you know you have a 45, 45, 90 because this is isosceles. So therefore, these two angles must be equal and divide 90 but divided by 2 and you get 45. So it's something I can't assume. And then Genevieve, I call this side the A side, and this is the A root 2 side, right? And that's what you want to do with this. You want to put those relationships around here. Look, this is A. This is A. And I need A root 2. So X equals A root 2. That's how you find X, because that's what A is equal to. So in this case, it's a replacement or a substitution. The only question I'm going to ask you is what's 4 root 2 times root 2? Ooh, what's root 2 times root 2? Let's do that first. Did you hear him? What's 2 times 4? 8. X is 8. So therefore, that is the length of that hypotenuse. So that's why this one's a little weirder and a little different. All right. Jad, are you next? Nice. Anyone have any questions on that? Again, you could do the Pythagorean theorem. It would just take longer. And actually, this is good to get this stuff memorized. No, that one's too easy. Actually, does anyone know what X and Y are? This is one that you should be able to get right away. David? 9, because that is the A root 2 side. So if this is the A root 2 side, then these are A, and that means they have to be 9. So that was fast. That's why you want to know this. All right. But then the worst one that we could run into are things like this one. Oh, no. All right. And yeah, I think we're doing all right. What do we have till 57? Is that right? 9:57? Okay. So we're going all the way, man. This is honors, but we do have a lot of stuff to do in our shortened time together. So I have to make a little video on the 30, 60, 90s, even though I will introduce it. Okay, so here's what we do next, Jad. This side we call A. And by the way, Jad, and I know this can be confusing, but I want you to stick it with A root 2, because sometimes they ask you to find variables X and Y. And I want to go back to the original, compare. Again, Jad and everyone else, you should know that this is a 45, 45, 90 because these two are equal. So those are added things to these drawings before you can proceed on. And then this side is the A root 2 side. This is where this gets confusing. This is the hardest one of the day. What do I do in order to find A? That's what you do. Okay, since this is the A root 2 side, and I know what that side is, I use that information to find out what A is. And then therefore I will find out what X is. Okay, knowing this relationship here. And then I got an easy question for you, Jed, or maybe not. Maybe you don't remember. What's 12 root 6 over root 2? You're right. I'm covering the 12 because you can just look at the root 6 over root 2 and divide those because they're both underneath a radical. So it does end up being 12 root 3. And that's where this gets a little weird. These are the least popular of questions students run into. just working with this. And I will tell you this, it is kind of silly, to have these kind of questions, but it's not. It helps you memorize this because this is huge in trigonometry. It is ginormous taking trig of these special right triangles. It is a huge component of our trig class coming up. Like the whole semester, they have to know 45, 45, 90s and 30, 60, 90s. Ginormous. Okay, so going to skip to the 30, 60, 90s as we finish. I'll probably in the video do a couple more 45, 45, 90s and then really hit the 30, 60, 90 relationship so you can get it memorized. Try to keep it at about 15 minutes for you to tomorrow. Okay, now I'm not going to be able to derive this one. But now this is a second very special relationship. And when I say 30, 60, 90, 30 and 60 are the other two angle measures in this triangle. Okay. Now off to the side is the things that are true, but I'm going to put it in this triangle in terms of A again. The starting side of this is the smallest side, and we should know this in general geometry. The side opposite the smaller angle will be the smallest side in the triangle, right? That's number one. We will call that A again. I lost my pen right in the middle of drawing. Somehow something happened there. So I'm going to use that letter A again. Couldn't care less what Stronowski or Fasola are doing. I always call it A in trigonometry or college algebra trig, the senior class. Then the side opposite the 60 is whatever A is times the square root of 3. Memorize. There is no I don't get it. You memorize that. And then the side opposite the 90 will be whatever A is times 2. And then that's what's true with the 30, 60, 90, all of them. Then I'm going to kind of piggyback to, what we just took a quiz on, similar triangles. All 30, 60, 90s are similar. They'll have proportional sides, but that proportion, this relationship will always hold true in every 30, 60, 90 scenario. Every single one of them. Okay, and again, it's nothing to get or not get. It's something to memorize. Really have to hammer that down with you. So Cecilia, did you go? But this time, no? Nice. So here we go. I'm going to try to keep this showing right here. And we'll do what I consider an easier one. Look at the side opposite the 30-degree angle is 31. So what does that make the side opposite the 60 based off of the A root 3, 2A thing? So what's the side opposite the 60? Side opposite the 30 is A. Side opposite the 60 is A root 3. So what does that make Y in this case? Yeah, huh? 31 root 3. Now this one, you do not have an escape with the Pythagorean theorem. And the 45, 45, 90, you could because you have two equal sides. This one, you have to know it. Okay, you cannot find these two missing sides without knowing this relationship. Then what's the last side? And this is just 2 times 31, which is 62. So that's the point of knowing this. This one, Pythagorean theorem, will not help you. Understood? Okay. So I'm going to do a couple more of these. I'll probably look at this chart, filling that out. Maybe one more of these complicated 45, 45, 90s, and then definitely a few of these 30, 60, 90s. So it won't be too long, okay, of the video that you just have to look at. All right? All right. Good to go for now. And we'll shut this sucker down.